next we have Kim and Marcelo from Niagara Parks, who will be telling us all about their new attraction, the Niagara Parks and Power Station attraction. Kim?
Yeah, thanks very much, Dana, and thank you everyone for joining us this evening. We're very excited to be sharing this really special project with you. So I'm joined tonight with my colleague, Marcelo Garoso. So I am Kim Viney, Senior Director of Business Development for Niagara Parks, and Marcelo is the Senior Director of Engineering, Parking, and Transportation. And between the two of us, we're the two senior leaders of this very exciting new attraction, which will be opening on July 1st. So in this presentation tonight, we're going to share a little bit about Niagara Parks, the history and science and engineering of the power plant itself. We're going to take you through a sneak peek of the reimagined power station experience, and then the progress on our construction updates. So if we have time, we'll have some Q&A at the end, but if we don't have time, we will look to answer those questions offline. So we're going to start with just a little bit about Niagara Parks. I'm sure you've all heard of Niagara Parks, but probably don't know much about it. So we'll start with a little intro video here. So apologies, our sound is missing on this video. However, this will give you a good idea through the visuals of just how far encompassing the park really is. So as we look at the park itself, Niagara Parks is the environmental and cultural steward of the 56-kilometer Niagara River corridor. So that corridor runs right from Fort Erie up to Niagara-on-the-Lake. And we are very unique. Even though we're an agency of the province of Ontario, we are 100% responsible for all of our revenue generation. So it's through our retail and attractions and culinary that we actually raise all the funds that allow us to provide the stewardship and the maintenance of the parks. We also have our own police service, which is the oldest police service in Ontario. And we also support many live events throughout the year. So in terms of our guiding principles, when we were founded, we were recognized that there should be no permanent financial burden placed on the province. So that speaks to our ability to be self-funded and self-sufficient financially. Also, as much as possible, the park should be free to the public. However, that does have a bit of contradiction that we do need to raise funds through our attractions and retail and culinary in order to support the rest of the efforts of the park. These continue to be our guiding principles as we operate every day. So now I'm going to turn it over to Marcelo, and he's going to take us through the history, science, and engineering of the power plant, which I think you'll find very interesting and a great tie to the Tesla story that we just heard about.
Thank you, Kim. So just a little bit about the chronology, which does tie in very nicely, as Kim said, to the video. So in 1892, the Canadian Niagara Power Company was formed by William Rankine. He also got some Canadian and American investors behind him. In 1893, that same company broke out and created the Cataract Construction Company. And the president of that company was Edward Dean Adams. So they basically put that company together to win that bid against Edison to build the power station in Niagara Falls, New York. So from 1893 to 1895, that's where Westinghouse builds the power system. General Electric builds the 25-mile power transmission system, and the Adams Power Station in Niagara Falls, New York is born. In 1896 is the first time that Buffalo receives power generated from that station. And then as you saw in the video, by 1961, the power station is shut down. And we'll go to the next slide. Two of the buildings, the one to the left and to the right, are actually taken down. And the center building is the one that remains as the transformer building, which you saw in the video. Go to the next one. So this plaque, I think, says a lot about the contributions of Tesla. So it identifies that 9 out of 13 of the patents utilized in the power creation and power distribution were through Tesla's amazing patents. So you can see them here, electromagnetic motor, but the big thing was the electrical transmission of power and how that was done. So now we'll move on to the power station, which was originally constructed in 1901 and 1905. Now this one is built on the Canadian side. It's also pretty much a copy, or a lessons learned from the American side were then taken over by the same company to the Canadian side. So in order to manage the volume from the river, this station required also a large tunnel to expel water once it had done its purpose. And we're going to go through that. We're going to show you all about that so that you really understand all the equipment that's left in this plant and how it functioned. So here's some amazing photos from the archives of when the power plant was built on the Canadian side. So you can see kind of working top left to right, you know, where they're digging, getting ready to create the forebay, which would house all the water, the type of equipment that they used, steam powered, a lot of leverage, a lot of mechanical engineering. In the third photo, the steel structures, massive steel structures that were built. You can see the people standing in them and how large they are, and the construction and manufacturing behind it. And then on the bottom 3 photos, you can see more of the build of the plant. The middle photo is actually the portal where the water would exit after it was used in the power plant. And to the right, you can see the facility that was created by basically steel and masonry efforts. So a little bit about the chronology on the Canadian side. The doors opened in 1905. Power was generated by July of that year. So Canadian Niagara Power, when it began generating electricity from the Rankine station, it became the first hydroelectric generating station to be built on the Canadian side of the river and to transmit power for multiple miles. So William Birch Rankine, he did pass away 3 days after the station opened. So unfortunately never even got to see the power being created in the plant and transmitted the distances. But later on, they do rename the facility or put a plaque on the facility to give him tribute. So here's a photo, and the reason we put this photo up is I want you to see and look at the arches at the bottom of the photo. That is the beginning of the process as the water is directed into the facility. And you can see behind it some steel structures, which we call the trash racks. So to the left, you see the complete facility. You also see the similarities to the Dean Adams power plant. And on the right, this is the water that has just entered through those arches we looked at. And there's the trash racks. So the trash racks would stop any garbage, fish, large fish, you know, branches, anything at all from going into the system that we're going to walk you through in the power plant. So just a couple other key dates. It took until 1924 to get the 11th and final generator into the building. As I mentioned, in 27, the plaque is added to honor William B. Rankine. In 28, basically Canadian Niagara Power opens up in Fort Erie. By 1950, Niagara Mohawk Power acquires the station. 2002, Fortis. Eventually, facility shut down in 06. And 09, Niagara Parks takes over and starts to put visioning exercises together to try to protect and preserve the plant and hopefully bring it to everyone who'd like to come see it as a brand new attraction. So here's a quick view. This is current updated photos today and some of the interesting facts around the power station. So we've already gone through the change in ownerships. The total capacity of the plant was in that neighborhood of 75 megawatts. Of course, a 25 cycle development, and we'll talk a little bit more about that. Current, at that time, it cost almost $5.2 million Canadian to build it. And an interesting fact about that, today that would be over $150 million. But you could kind of look at that and see the present value of those dollars. The online date we talked was July 27th, 1905, and by 1924, the last unit. And we'll start to go through a little bit of the equipment, so we'll go to the next slide. You've got the penstock that we're going to show you and what it looks like, the power station, local limestone, glazed clay tile roof, very beautiful. It's 570 feet long, 2 floors, This wheel pit, I'm very excited to show you that because it's one of the most cool experiences. It's at the very bottom of the plant. It's very long, the entire length of the plant, and it's about 20.5 feet wide. And then of course that tunnel where we'll show you that as the power or the water came in, it headed back out the tail race tunnel and back to the river. So very green, very ingenious. We'll move on to the next slide. So this is a nice shot from the top. So you can see that the Niagara Parks actually are stewards of 3 power plants. Number 1 being the Ontario Power Generating Plant, which is down in the gorge. Number 3 to the right being the Toronto Power Generating Station, because there was a battle going on as to who could provide this electricity and provide it those long distances to homes. And then in the core, in the center, is our Canadian Niagara Power Facility, which is now the Niagara Parks Power Station. And that's the one we're going to refer to. The one thing I'd like to point out, if you can see just in front of the power facilities, there's a structure where it starts to kind of cloud up the water, the cursors on it. Those are the weirs, and those were built to try to direct the water into the forebay area to begin the process. So something that's also very interesting is the underground infrastructure to these power plants is very significant, as you can imagine. So the one I wanted to point out on the left is the blue. It's very light, but that is the tunnel, which is approximately 2,200 feet. It sits 180 feet at the very bottom of the plant when you exit the wheel pit, and the water heads all the way back to a beautiful portal at the end where it goes back into the river. So one of the things I wanted to kind of ask, and you can think about this, is what wreaks havoc on hydropower plants? So the answer to the right is ice. So snow and ice in particular. And so one of the ingenious pieces of these power plants is they built that canal that you see here, which is called a sluiceway. So as the water came into the forebay, they were able to allow the ice to naturally flow right back to the river and hopefully not make it even to the trash racks. But when it did, you can see to the right, there was also a way for it to escape, connect again to the sluiceway, and head back to the river. So that was the most challenging aspect of bringing the water just to the start of the process that they needed to deal with, and this is how they did it. So I thought a very cool picture to look through. So you've seen this photo in the video, but a cross section of how the plant works. And we're going to do a little video that'll give you a very clear indication coming up. So just on this one, you could see the flow coming in through the forebay, through what we'll teach you about with the headgate, penstock, down the multiple layers to the turbine, and then eventually down to the very bottom rectangular area known as the wheel pit. And then to the right, you can see that the wheel pit leads to a tunnel that I showed you will lead back to the river. So here's a quick little video to show you the function, and then I'll be able to show you the equipment and how it functions. So hopefully you'll be able to see this shortly, and if not, I can walk you through it. So you see the water on the top left, a little bit greenish in color, a lot of lime, calcium. You can see the gate coming up and the water starting to make its way through the trash racks into the penstock. So as you go down the penstock, and it's buffering a little bit, you'll start to see near the bottom, the turbine starts to turn right there, and then through the turbine into the wall and back out to the wheel pit, and from the wheel pit down this beautiful brick-lined tunnel. And these floors are massive. You can see by the person on the right cross-section, kind of the comparison of a person, an average person, to how large this infrastructure is. So we're going to show you that. So at the very top, obviously, the turbine is connected to the shaft. The shaft goes up to the blue alternator. A lot of people will call it a generator. I will call it an alternator, which spins and creates the AC power. So we'll move on and start to show you a little bit more around the equipment. So I talked about a head gate. Once you come into the forebay with water, you make it through the trash racks, there's these massive steel structures that they were able to figure out the engineering and lift up and down as required in order to start the process. So we wanted you to have a visual of that. These are about 19 feet by 17 feet. So after the water comes in, the first thing it hits on the right-hand side, you'll see the curved section of the penstock. These are 10 feet, 6 inches in diameter, riveted steel structures. I don't know how they did it back then, but they figured it out. Massive, massive structure that they pieced together like a puzzle and took it all the way down 135 feet till it hits the turbine. On the left, you kind of see how they were doing it as they were putting it in section by section with, again, limited equipment. So if we can go on from there. Another interesting point is the selection of turbine. So we know there's a lot of different kind of turbine runners out there. So to the right, you can actually see when it's cribbed up and it arrives at the plant to be installed. And you can compare that to the photos on the left. So you can see that what they used was a Francis turbine, named after the individual who invented it. So the Francis turbine, what's very interesting about it is it's got a double set of blades. It's even used today in hydropower plants. It's based on Newton's third law. Any action will get a reaction. So it's a reaction turbine. The resulting motion, even though the water's coming in horizontally, you end up with an axial, basically transfer of load, which is perpendicular, and then the water drops down, the shaft spins, and does what we showed you. So very efficient, anywhere between 90 and 95% efficient. And the key is that it can stay at a constant speed as long as you can adjust the water. And we will show you how that is done in the plant. It's also ingenious so that you can keep the speed and direction. And it can be flipped. It's just in this plant, it was positioned in this fashion. So we wanted to explain that. So I won't get into this, but this just shows you that as they're putting in the turbines, the 11 of them, improvements are made. Different companies are manufacturing it. And some big, some names that you'd recognize today, like Bethlehem Steel, the Escher Weiss, if I'm saying that properly, out of Switzerland. So Wellman Seaver Morgan. But you can see that the horsepower grows as they're tweaking their design. But what always remains constant, because they picked a certain design, the Francis design of turbine, is that 250 RPM. And we'll show you on the next slide an actual turbine runner on the left. We can see the two sets of blades there. And then on the right, what the shaft looks like and how they put the shaft together. So you can see where it comes together at the flange. And then obviously, you can also see when it becomes smaller. And it's about 135 feet, like we said. We'll go to the next slide. Just more of a technical drawing that the way that the water was brought into the turbine did change as they progressed, and that's what allowed them to tweak their design, get a little bit more horsepower, a little bit more head, in order to get a little bit more work out of it. So next, just some really cool equipment that's down in the lower areas of the plant. This is a pumping, basically a pump, massive pump system. So that as the water came in, they were able to pump it through the entire plant for cooling purposes, and to use it throughout the plant for many functions. Another cool piece of equipment on the next slide is an air compressor. I don't know if it's one of the first air compressors made, but again, always using water to turn these different devices or inventions, and they were able to create compressed air and use it again throughout the facility for different purposes. So some incredible equipment. Just wanted to give you a visual of the alternators that are still in the plant and a cross section so you could kind of see the rotor, just the basic principles of a motor, and we'll really get into how these create the AC power and Tesla's ingenious invention, of course. So when it comes to these alternators that we just showed you, you could see, again, progress between units 1 to 5, the first 5 in the plant, and then how they were able to increase the amperage as they went 6 to 10, and even a tweak in the 11th one. So always continually improving, just like technology today. I just threw this up for people that are interested, but in terms of, they had already made a decision on the Francis turbine, and that really, the fact that it's already a set size and diameter and really speed, and they had a fixed head, really the difference between where the water comes in and when the water hits that turbine, they were really kind of stuck with going ahead with 25 hertz power. So you can see as it lines up, 200, if you go to RPMs at 25 hertz, you're at 250 RPMs. If you scroll to the left, that means that they had to put 12 poles inside the alternator. So they were kind of stuck. I just wanted to show you that the decision had already been made in the Dean Adams plant. They already selected the turbine, they were on order. So that kind of fixed them into continuing to go with 25 hertz and not switching to something like 60 hertz, which later on in the plant was a bit of its demise. The conversion to 60 hertz would have cost too much, and there were other issues, of course, as well. Okay, so this is an important part where we learn about the DC. So there's a little bit of Edison in the plant because he came up with DC. This panel is a DC panel, and on your right, I'm going to show you in a bit the exciter, which is also generates DC. So these switches here, they powered up a DC elevator, the lights were DC, and several other things in the plant were DC. So we have a wonderful combination of DC power and AC power in the facility. So the next slide, please. So this is what I call an exciter. I've been corrected many times by people that know a lot more than I do, and they call it something a little different. But what I can explain is, if you look at the right when it was initially installed, to the right, you see two kind of chambers or two housings. The right is the motor, and the left is the generator. So you needed the motor to start spinning, which at one point in time was done with water. So now you're turning an AC motor by Tesla, and then you're creating the generator. The generator is creating DC power. And next slide, the DC power goes into the alternator and creates the magnetism inside this alternator. So once you create the magnetism, now you have the complete package that Tesla came up with for generating AC power. The rotor spinning, the DC power is turned on through those exciters, and basically now you have the windings for the three AC lines to go through. So I just want to show some of this incredible equipment. On the left, number one, is the governor. So as the water came in through the forebay, through the trash rack, down the penstock, you needed to be able to adjust it so you could get this thing spinning at 250 RPM. The way to do that was through the governor and the big wheel. And up on top, you could see a tachometer, or you could see basically an RPM reading. They would tweak that amount of water, because as you move that wheel, it was all intricate mechanical devices that opened up a ring valve and adjusted the amount of water in order to get that alternator spinning at exactly 250 RPM. Number two was an air brake. So I showed you the air compressor. It needs air, and that was the ability that you could put on a braking mechanism, and the braking mechanism is number 4 on the 3rd floor of this power plant. You have a massive drum and ability to do a bit of braking. Now you can't stop the massive momentum from a 250 RPM alternator in one shot, so they would pulsate the brake and slowly bring it to a stop. And then number 3 is the ability to actually lock the brake in position if they're going to work on it or do something to the equipment. So some really cool pieces of equipment. That governor is unbelievable to see in real life and understand how it functions. So next slide. So the control room, this is another incredible piece in the plant on the 2nd floor. You can see all the different ability to read with gauges back, 115 years ago, all the different gauges where the operator, was really in charge. They would watch the reactive VARs so they could know if it was lagging or leading the power. They could see the megawatts being produced by each generator as they turned on each one. And then they had to watch the current in the voltage because everything has to be in sync. And I'll explain that a little bit more. And then to upper right, this will be important when I explain how everything ties together. but important that you could see a plug that they plugged in, and that plug would turn on the synchrometer, which is that round device at the top of the picture upper left, which helps them make that decision of when they can connect that alternator and send it out through the cables. Because if you connect it at the wrong time, you have a big problem. So just a quick kind of explanation of how that works, and maybe it's overly simplified, but this is how I think about it in my brain, is when you're doing skipping and you've got two ropes going, and those almost, are creating the waves. So we used to call it double dutch. I don't know what it's called today, but you're skipping. You have to be able to jump in at the perfect time. If you jump in at the wrong time, you hit the rope, it's done. The same thing would happen here. When you turn on an additional alternator and you're creating more power, if you don't go in at the exact time that's right, where everything is in sync, you can blow things up. You can create fires, you can blow things up. So anyway, just kind of neat, all this equipment and all the thinking of how it ties together. So next slide, please. Just kind of a cool old photo. This is how they communicated between the floors. You can see the old kind of phone devices. And then on the right, on every single floor, was one of these very cool kind of carved up, made booths from the staff. And in there was a telephone. So that's how they would speak between each of the different levels, as they had somebody on every one of the decks to monitor what was happening during the power production process. So next slide. So these are the breaker panels. So I like to describe it as you can think of a breaker in your home when you're going to flip on the breaker and you're going to get power to certain plugs or certain lights are going to turn on. It's the same idea here. Before you could put an alternator on, and we'll go to the next slide, you would have to turn on the breaker. So this is what the breaker looks like inside. You can see the same device on the very top. But what happens is when you turn on this breaker, basically the switches drop down and hit the canisters. Those are filled with oil, and oil is to keep things cool, and it has to be done very quickly in order to not create any arc or not create any massive sparks or what we call arc flash, because if that happens, you'll blow the doors right off these. We took the doors off so you could see it. So interesting kind of breaker setup between the operator on the second floor and the operator in the main control room that I showed you. They have to talk. They have to hit the switch. When the synchrometer hits 12, that tells them that's the right time. They're not going to blow anything up. Then these crack down, make the connection, and then we'll show you in the next slide the synchrometer. We'll flip to the next slide. So once you close the switch in the middle or your breaker, it has to flow. You can see the big copper bar right underneath. And to the left, those copper bars are in each of those phases. They're labeled phase 1, 2, and 3. That's called the bus bar. So that takes that load, that electricity that's coming out of that alternator, the big blue machine, the breaker's closed, it flows through the copper cables, through each of those phases are going through a long copper bar, and eventually to the right, go through the cables, and then the cables will take it out to where the power needs to go. So an understanding of the process. If we go to the next slide, I just wanted to quickly summarize. So to the left, you've got the power of the falls, which is unbelievable. And I think, they said how many incredible amount of gallons go over the falls. So they redirect some of that water over to the forebay. The water goes through the trash racks to protect any junk or any garbage. They can slowly lift up that big steel gate in photo number 3. It starts to allow the water to flow into the penstock. In photo number 4, it drops 135 feet and spins the turbine, the Francis turbines. They're 130 feet down. That load goes, even though the water's coming in horizontal, it now turns the shaft perpendicular, which you see all the way back up, and is connected to that alternator, with that governor giving you that ability to get the speed and the amount of water just right to get it to 250 RPM. So now you flip to the excitation, because that's only a motor, basically. If you don't have magnetism, you just got a motor, you're not really going to generate AC current. So when you come to the bottom, you've got this DC control panel, you've got the exciter that we talked about that spins the AC motor, goes over to the generator, generates the DC power, which feeds the big blue machine. You're in the control room, you're watching the synchrometer. When it strikes just before 12, he's talking to the operator. Somebody's talking to the operator on the second floor. You close the breaker. You've got the electrical panel. The way you close it is one of those switches, one of those knobs. And as I showed you, the power eventually goes out the cables. And basically the last slide, you've got power for the lights in Fort Erie. So just an amazing process with amazing people. Tesla at the helm in terms of all his patents, 9 out of the 13 that actually make this plant work. And the beauty of it is we have it all in the plant that you can see, you can touch, you can understand. It's incredible for me as an engineer to be part of it, and hopefully it'll be incredible for you to come see it and experience it yourself as well. So the tunnel is basically when the whole process is done, the water drops into the wheel pit, this big rectangular chamber, and then starts to head out 2,200 feet and make its way back and drop right into the river. Right by what you're looking at on the bottom right is the Bridal Veil Falls, or the American Falls. So you can't ask for greener than that. We borrow the water, we put it back, and power to everybody's home. And there's just a beautiful visual of the plant 115 or more years ago and the plant today. I'm going to turn it back to my colleague Kim and let her take you through the reimagined power.
Yeah, thank you, Marcelo. So what we'll do is we'll take you from the science and technology of hydrogeneration, excuse me, to how we're bringing this old plant to life. So we're taking it out of hibernation and we're bringing it to life with both daytime and nighttime experiences. We'll go to the next slide. So we're going to see whether this video will play or not. If it does play, this will just give you a brief overview of the project that we're now working on. Oh, looks like we're going to have to leave that one for now. So in terms of the phasing of this new attraction, so we will be launching July 1st, 2021 with both the generator floor tour and our immersive multimedia show, which is our nighttime experience. 1 year later, we will be then producing the tail race tunnel experience. And then for future opportunities, we hope to create some linkages to our journey behind the falls and to other infrastructure in our area. So in terms of the plant itself, it is full of these beautiful details, these beautiful materials. There is copper everywhere, there's texture everywhere. So we will be using these as sort of a reference point and inspiration for all of the work we're doing. Also, there are lots of interesting nameplates and shapes and typography and valves and switches. So again, these will all be made use of as we do the design work. So as Marcelo mentioned, the new name of the attraction is the Niagara Parks Power Station. And again, we've got this lovely logo with the iconic architecture, the reference to the nameplate, and using some of the topography that was historic to the plant itself. What we're doing is taking some of these lovely items and turning them into merchandise for our retail store. So even some of the Tesla patent drawings we will apply on some t-shirts, and we'll have scarves and hats and keychains and a number of items for guests to take home. We'll also have a number of Tesla books and books on the power station itself. So we'll really have a fulsome experience for everyone. So in terms of the daytime experience, so we're busy working on the interpretive plan. So we've done a lot of research into all of the elements that created this plant. And we are going to tell this very rich cultural story. We're also working with Science North, and they are developing 3 key exhibits for us. So we will take you through those 3 exhibits. And this experience will be both self-guided, and we will have guided tours available each day as well. So in terms of the key interpretive plans, so really at the heart of this storytelling is harnessing the true power of the falls. So why was this plant put where it is? You know, it matters because it is beside Niagara Falls itself, that's what matters. That's why they put it there. So we want to share that sort of sense of place, of history and geography. And then the plant itself, the beautiful architecture and construction. And then in terms of power, this is where we get into science, technology, and innovation. So we want to sort of pay reference to the science and technology it took to build this plant, and certainly Tesla's inventions. But also we want to look to the future. So where is power going? Where is sustainable power going? Where is green power going? We really want this to be a living building that can celebrate and bring all of these new ideas to life. So in terms of the development of the interpretive plan, as you can see, we've created zones within the plant. So all of the interpretive work will take place in the generating hall itself. And you can see the variety of stories that we will be telling throughout the plant. And then the forebay area, Marcelo and his team have been working very, very hard. So much of the forebay area is actually being concreted in to create retail and culinary space, but we are leaving a section of the water in the forebay area open just so guests can understand how the water came in from the river into the plant and then through the penstocks. So in terms of collaboration with Science North, many of you know their work in terms of the Science North Museum up in the Sudbury area, but they also do work right around the world. So we're been very happy to work with them. So the first of the projects we're working on is called Follow the Flow, and this is actually a scale model of the plant itself. So this model will be about 22 feet long and about 12 feet tall. And really a couple of things that we're trying to show with this model. So first, it's almost like this plant is like an iceberg. So even though the building you're standing in seems quite immense, as you look at the model, you realize that really so much of it lies below grade, that really the smallest part of the building sits above grade. And also that animation that Marcelo shared earlier, that animation will be visible as these huge animated graphics on the end and the side of this plant, along with interpretive panels to help explain all of that science and technology that Marcelo just took us through. So the second of the Science North models is we're going to actually bring to life this old control panel. It's such a marvelous artifact that's been left to us. So we'll go to the next slide and I'll explain what we're doing. So it's actually a bit of gamification. So this is going to be a lot of fun. So there'll be a large screen mounted on top of the control panel, and we will have 3 or 4 scenarios built where guests will be invited to come up to just your activated screens on a rail in front of the control panel. And essentially a scenario will be set out for you. So there may be an emergency where, as Marcelo said, maybe a log or a big tree came off in a storm and it's starting to block the trash rack, and maybe part of it got into the penstock itself. So the guests will be invited to sort of become part of that storytelling, be part of the solution, and through the tablets, they'll be instructed to do various things to help solve the problem. In terms of the penstock itself, you know, at 10.5 feet tall, we really want to give guests the sense of how big these are and how much water came into the plant. So they're actually building a replica of the penstock, which guests can walk through. As you approach the penstock, lights will come on, so you'll see water inside of it, and then you also hear the rush of water, so there'll be an audio component to this as well. This will lead you over to a glassed floor area where you'll be able to look down and get a sense of that huge drop that these penstocks took down to the wheel pit area, and that's what turned the turbines. So also we're creating an interactive guide, which you can use your own handheld device. So through these guides, we will have scanning markers throughout the plant, and this will allow you to get deeper information on a variety of the topics that we'll be touching on in all the immersive displays. Also, it'll be an audio guide, so you can either bring your own earbuds, or we'll have earbuds for sale. And this will also allow us to provide some of this guided information in multiple languages. So in terms of the night experience, this is where things get really, really exciting. So we're working with Thinkwell out of Montreal. And Thinkwell are well known for their beautiful shows and spectacular shows they actually create all around the world. So we'll be using both the laser lights and a variety of effects, including projection mapping and reactive technologies to create an amazing, wonderful spectacle of a show at night. So the show itself is called Currents, Niagara's Powers Transformed. And I'll take you through a little bit of our thought process that we've been working on in terms of the creative. We're going to see whether or not this video will play for us. It's a bit of an overview from our partners with Think Well out of Montreal.
So this project here is very special. We're in a very old building that has been sleeping for about a decade, a bit more. And before it was breathing, it was living. It was a really kind of living thing, and that's exactly what we try to reach here. It's like to take this building and to bring back life. My name is Antoine Roy-Larouche. I'm a producer at Think Well Studio Montreal. So this immersive experience in the night will take the guest at the very center, at the core of the building, and by their presence, they're going to wake up the building, to wake them up, and to make it breathe again.
For people to understand what an immersive experience is it's almost like
Okay, it looks like we'll have to leave that video. We will be able to provide a link to everyone, so will be able to watch the video on your own. But in terms of the show itself, we really want guests to feel like they are immersed in this show, and actually through new reactive technologies, they will actually interact with the cause and effect of the show itself. So the show producers have infrared mapped the entire show floor. So that includes the wall and the floor itself. And as guests enter the experience, you're actually going to start to see water be created at your feet. So rivers of water will actually start to follow guests as they enter into the show space itself. And the more guests who come into the show space, the more water will be created, until what point the show, all of a sudden, there's a lot of water on the floor, the show will go dark, and then the show itself will start. And I'll show you a couple of video clips, I hope, that will show you a little bit of what I'm speaking of. So this first one will give you a sense of the water. We really want to sort of mimic Niagara Falls rushing down the wall of the show and onto the floor. And through the video mapping, they actually will be able to understand both where the alternator cabinets sit, but also where guests are standing. And as you stand there, the water will actually sense where you are positioned and will run around your feet. So we will show another clip which will give you a sense of the scale of this as you're standing as a guest. So you can just imagine how powerful this is going to feel with all of the surround sound that will accompany this. So the next clip we're going to show you is, the story is sort of macro to micro. So we actually want you to feel like you are becoming part of a droplet of water. So that's what this animation is starting to create. And then as the water turns to electricity, we actually want you to feel like you are a piece of the electricity. So again, the same way that you reacted with the water, you're going to react with these electrical currents. Depending on where you're standing, electricity will run between you and another guest. As you move, electricity will follow you. It will run between you and some of the artifacts in the plant. So you're going to feel very much like you are part and parcel of this charged electrical particle. And lastly, the part of the story takes you back 12,000 years to the Ice Age. And we'll actually show the Ice Age as it starts to dissipate, the ice itself starts to dissipate. So using some of the architecture of the building to create these ice forms, and then these ice forms collapse and create water, which then creates the Great Lakes, which of course leads to the creation of the falls. So that gives you a sense of some of the really fun animation that's being developed for this show. They have hired a score writer out of LA. So an original score is being written to accompany the show, and the show will run every night from about 6:30 until, in the summer months, probably till about 11 at night. So it's going to be an absolutely wonderful addition to the generator hall experience that we offer in the daytime. We'll go to the next slide. So in terms of the ancillary services, so we really want to be respectful of the design of the plant, the sort of industrial history of the plant, and kind of that steampunk look and feel. So everything we're designing in terms of retail and culinary will keep that same kind of mood, if you will. So the fixtures will be rough pipe with wood. We're using some of the artifacts and sort of recreating some display areas with artifacts. We'll have artifacts placed in and around the culinary and retail areas. And just keep that lovely patina. Just the only things that will have sort of a modern vibe will be some of the service areas. We just want them very clean and sleek looking as a contrast to the really wonderful industrial look of the rest of the offering. As I mentioned, we are repurposing some of the artifacts. So those big valves that Marcelo spoke of by the governors, we're actually turning those into high top tables. We're looking at taking some of the old control panels and perhaps creating some coffee tables. There are these wonderful Westinghouse racks that we're using to create some of the racking in the retail store and some of the benches. So really, it's going to be a fun combination of old and new brought together.
We're standing today in a very special place in the heart of Queen Victoria Park in Niagara Parks. From the moment our guests step in, they're going to be in awe of the scope and the scale of this new attraction. The fact that everything is still intact in this location, it makes it unique. And I want you to step back to the turn of the 20th century when there's competition going on to build hydroelectric power plants in the Niagara corridor to harness the power of the Niagara River. So here, for this location, hundreds of workers basically doing an open pit construction. So using horse-drawn carriages, lots of dynamite. So you can imagine for over a 4-year period, this construction activity going on, which led to the completion of what became really one of Ontario's first green energy projects and led to the industrialization of Southern Ontario and Western New York. A year ago, we worked with the Ontario Heritage Trust to host Doors Open, and we had great success. We sold out in less than half an hour of the tickets that we had for that particular weekend in October. And it gave us that confidence that there was a huge interest in this building, in industrial heritage, and in the story of hydroelectric power generation that we're going to share with our guests when we open on July 1st, 2021.
Phase 1, our guests will experience this gorgeous generator hall full of new exhibits, interpretive elements. We'll do group tours, and also a really wonderful culinary and retail offering featuring some of the artifacts that we pulled from the plant. As we move into phase 2, we will be opening up an elevator down to the thrust deck level, which is a level below the main floor. We take them down 160 feet. It will be the same direction that the water had traveled, then return to the Niagara River. So as they walk 0.7 kilometers through a very interesting tunnel and exit at the end, they're going to see an amazing view of the river and Niagara Falls as they look off to the right and left. The nighttime experience is our immersive multimedia experience, and this is going to be an absolutely spectacular show. This experience is going to be developed for all audience types, and really guests are going to watch as this dormant plant comes to life again. They're going to watch through video mapping and projection mapping that the turbines and the power plant starts to hum. Earlier this year, our ministry challenged all of us as agencies to see if we could work together. So we were very excited to bring Science North into this project. Clearing their expertise and experience with what they offer up in the Sudbury area would be a great fit for us. So we've really enjoyed working with them, helping us bring to life 3 of the very key exhibits that we will be offering in 2021.
One of the key aspects of our approach to exhibit development is really being collaborative with all the people that are involved. So working with the Niagara Parks team to understand their goals for the project, speaking to past operators and plant personnel to get their input to be sure we're authentic to the experience. We really hope that every visitor that comes in here is, first of all, awed by the grandeur of the building and the existing machinery, And that when they interact with our exhibits, that they really take away a moment of appreciation for the underlying innovation and what this really meant to Canada and electricity generation.
Niagara Parks is at the heart of Canada's premier leisure tourism destination, and we are very proud to be opening the next new attraction, not only for Niagara Parks, but also for Niagara. This will be a catalyst to drive new demand generation to Niagara and to Ontario, starting in July of 2021.
Okay. I'm back. So I'm just glad we were able to show you that video because I think that was important to give you a real view of what's happening. I'm just going to give you a couple quick project updates from a construction perspective. So just what we've done in the forebay itself is we've basically created a brand new wall to hold back the water. Now from the road, from a heritage perspective, people won't even know, they won't be able to tell. The arches will still be visible and water will still be entering into about a 100-foot section with trash racks so we can show exactly how the plant functioned. And then basically this becomes the area, our basement or our area basically for all our electrical, our sewer, everything, so that we do not change anything inside the plant. We protect everything. So you can see we're working our way to actually pouring the floors in the forebay. That's what these pictures show, and we're actually just about done as of Friday. Get a visual here, and then we'll start, with the insulation, the ceilings, and starting to create the washrooms, the culinary experience, and the retail experience, which will come in phases over the next few years. And this just shows you whenever you touch a plant that's over 115 years old, you're going to find some issues. So on the left, we had a failed roof just above the forebay that we had to replace. And then out in the area that we dewatered, being over 115 years, once we pulled the water out, we had to do a lot of different repairs, concrete repairs. That just gives you a feel. And then the cranes had completely seized up, but we were able to position one of them so that we can tell the story and use it as part of an exhibit. And we left the north crane in the other, in its home position. Both cranes were 50-ton cranes. That gave you 100-ton capacity, because when you lifted one of these blue cases off and you were to take the rotor off and sit it down to work on it, it was almost 70 tons. So you had to use a spreader beam and 2 cranes in order to lift it, which is incredible. Next. And just the tunnel experience that Kim described. The guests will travel all the way down, and this is the incredible view at the very end. So they'll come down 2 elevator cabins that are being built and installed with a brand new shaft. It'll take you right down to the wheel pit where you can explore the wheel pit a little bit, which we showed you some images. It's an incredible space. And then you can start your walk. It's going to be accessible, lit, and you'll come to the end where you've got this, $1 million view. And that's expected for 2022. And that's it. I see some questions are coming through, so I'm going to try and, I believe, answer those, direct over the next few minutes. Or I could do them on the air if Dan, you're still there. So I'm going to have a quick look here. So there was the Cataract Power Building in Hamilton. How is it related to Tesla's work? Very much the same as the plant in the US, the plant that we have here in Canada. Hamilton did receive power but from DeQ Falls, and it did use the same patents. I mean, the patents don't change. The technology was all around the same time, and it was Tesla, and it was, and I failed to maybe mention, but Westinghouse obviously was the brains behind building the equipment and bringing it to life. So that incredible combination. How often would turbines have to be replaced? Now again, so I didn't work in the facility, but the feedback that I get from individuals that did and maintained the facility was they tried to keep them running as long as they could. They often had to bring them up for big repairs. They had their own tool shop. If they could weld a broken blade or a damaged blade, they could do that. They had the skills to do that, but they did replace, from the gentleman I spoke to, he was there 37 years, and he said they replaced probably about 8 of the turbine runners over his time. So, not a bad situation, I would say. So very robust equipment. But of course, if, as Kim described, if a tree branch came through or something got through because the trash racks were left slightly up, then you could have a massive problem with some damage to a turbine runner. Just looking to see if there's any other questions. I think that's all of them. If anybody has any other questions for myself on the plant itself and the construction or the technology, or for Kim on the new attraction and what Niagara Parks is doing for the Niagara Parks power plant.
I've gotten a few text messages saying that this presentation and the behind the scenes view of it all that you've presented is absolutely amazing, and there's a lot of excitement, and so it's a lot of fun to see this, so thank you.
Yeah, you're welcome. We're glad we can share it. It's really iconic to Canada, so it's just an incredible experience for all of us to be part of it, including everybody on this call. If we can, if you want to come down and see it when we open, we'll walk you through. It's going to be an incredible experience.
And we have been recording this, and we will be posting the video to our Activity Week webpage. So it is able to view for classes and other guests in the public that will be able to see this and see the work and the effort that you guys have done, and it's just incredible.
Okay, thank you.
So I don't see any more questions coming in, so